Okay, so I'll keep this up for another minute. I'll put it up again tomorrow, but if you guys wouldn't mind just getting that taken care of, something I have to make sure gets done quickly. So today we're going to finish the review notes, and we're going to be doing the factoring stuff. It's kind of a lot of notes, a lot of me having to give examples, but I'm really going to teach factoring to you in 30 minutes, okay? For some of you, it's a review. Yay. For some of you, you hate factoring. Well, most people hate factoring, but for some of you, you never were that great at it. Bottom line is, moving forward, we all have to be good at it, okay? So I'm going to, give you a review examples of every type, and then you might notice, if you just turn the page, that there's a really long worksheet there. As always, don't let that scare you. You'll start to learn. I'm only assigning 4 of those problems, okay? So you'll probably finish it in class. If not, you have a tiny bit of homework. So don't stress. Like, I just know the kind of student I was. I was always kind of nervous. I have so much homework. She's still talking. Why is she still talking? There's a big long worksheet. And I don't want you guys to stress about that because I definitely cut it short. Tomorrow is reviewing for the quiz, okay? We're going to have a quiz on Thursday on these 3 sections, okay, in class quiz. And so tomorrow there's not a new assignment, or I'll probably just give you points for just working. But tomorrow will be me not teaching. It'll be me walking around helping you. I'll assign some more factoring problems to make sure you review, but don't worry, you don't have to do the whole sheet, but they're there if you want to. And then anything that you didn't understand with interval notation, go back over your simplifying radical stuff. I just thought of something. I'm about to lose my juniors. Half of this class, more than half this class, are 11th graders, and you guys have your assembly this period. So if you are not a strong factorer, you're going to have to go back and look at this. And you could use tomorrow's class time to do it. If you have your laptop, you can use tomorrow's class time to do that lesson. Just be sure you know how to do the other 2 days, okay? Because tomorrow is just clearing up any kind of questions you may have, right? So let me try and get started as fast as I can. But remember, you can go on Canvas and see the completed notes. You can see the worksheet and the key to the entire worksheet, okay, even though I'm only assigning 4. Right? Any questions for me before we get started? No. Okay, one more thing. The packet is pink for a reason. I think I talked about this. Anything I give you on pink paper means it stays in your notebook all year. I'll be giving you lots of pink stuff throughout the year that are just super important to be able to look at throughout the year. And so later on in the year, if we get into a problem and the first step is factoring, and you're like, oh my gosh, I forgot. You know where your notes are, and all of the modules on Canvas will stay there the whole year. So you could just find the module that says Algebra 2 Review and go back and watch whatever part of the video you need help with, okay? So I leave everything there for you, and I try to set you up so that there's somewhere for you to go always to help you if you get lost or behind, okay? All right, so basically, we broke this down, factoring, into 3 steps, and within the 3 steps, there are 3 general types of factoring. We have 2 terms, 3 terms, and 4 terms, or 3 types of polynomials that we factor. Within those number of terms, we can break it down a little bit further. So let's start with 2 terms. So this first step is factoring out of GCF. You should train yourself to look at a polynomial and say, okay, is there anything I can factor out first? And we'll see some of that later, so I'm just going to get right into the other stuff. Okay, so what I want you guys to notice is there's 4 different types of 2-term factoring. Those are binomials, okay? You'll see a plus and a minus with squares, and you'll see a plus and a minus with what we call cubes. So let's start with the squares. So they kind of break down for you how to factor it. I'm going to give you an example for each. Okay, so for this one, for example, if I gave you 9x squared plus 16. First thing you notice is it's got 2 terms. It's got a plus in between. And we know it's a squares type of problem because we talked yesterday about perfect squares, 1 times 1, 2 times 2, and so on. And so we should recognize 9 and 16 as perfect squares. Variables are perfect squares if their exponents are an even number. That's simple. So that is one of these 2 types. the fact that it has a plus in the middle is very, very important. This cannot be simplified. That's why it says stop. There's nothing else you can do with that one. Just like yesterday when we were simplifying radicals, sometimes there was nothing else you could do to simplify the radical. That's as far as you can go, okay? There's nothing you can do with that. But let's put it side by side with its friend difference of two squares. So I'll use those same values, but put a minus in between, okay? That is able to be factored. Again, we notice it's got two terms with a minus, difference, some difference, and everything's a perfect square. Really, really simple to factor. We make two parentheses, okay, with two different signs. One's a plus and one's a minus. The order doesn't matter at all. And we talked about the perfect squares yesterday, and we also did them on our calculator. So if you didn't know what the square root of 9 was, you could use your calculator. But that's 3. So the square root of 9 is 3, and when we do the square root of a variable, you just cut it in half. So the square root of x squared is just x. So what we're going to put in the front of both sets of parentheses is the 3x, and then in the back of the parentheses, the square root of 16, which is 4. So 3x plus 4, 3x minus 4, order doesn't matter as long as one is positive and one is negative, okay? So moral of the story, you can do difference of two squares, but not sum. All right, so that's the squares. Let's move on to cubes. These are easy to tell what they are because they have variables that are to the third power instead of the second power. Still two terms, okay? So I'm all about the arrows today, so bear with me. So let's do a sum of two cubes. Again, two terms. I know it's a cubic because it's got x to the third. And let's talk about why 27 and 1 are perfect cubes, okay? Let's go ahead, just like we did yesterday, and develop a list of them, of the perfect cubes, okay? So yesterday we did the perfect squares. It was 1 times 1, and 2 times 2, and 3 times 3. Same idea for the cubes. It's just 1 times 1 times 1. It's the same number 3 times, okay? So 1 times 1 times 1, and 2 times 2 times 2, and so on. Now, you do not need to memorize these. 4, 5, and it goes on forever. Okay, you don't need to memorize them. I had some in my 7th period, I think it was yesterday, asked me, are you going to give us a list of the perfect squares? No, I'm not, and I wouldn't give you a list of the perfect cubes. I give you a calculator, okay? So you should be able to figure out what they are if you wanted to make a list of them, not required, but be able to kind of identify them. Let me show you on the calculator how to do cube roots. So yesterday, we talked about perfect squares and how to find square roots. So if you remember, square roots were the blue button, and then you have to turn the calculator on, just so you know. So yesterday we learned if you hit the blue button, is it blue on you, yours? Yours is blue too, yeah. Okay, so blue button, and then above the x squared is the radical. And then you could put any of the perfect squares in there, like 64, for example, square root of 68, okay? Now let's see where the cube roots are. So right now you're seeing why it's such a benefit for us all to use the same calculator, because I'm going to tell you where it is deep inside the brain of it, and then you'll be using it all the time. Then when it comes time for the AP exam, you're not like, oh my gosh, why is she giving me this strange calculator? I don't know how to use this one. I want you to use the one all year that you're going to use on the test. But like I told you before, if you have a graphing calculator that you've used in another class, a sibling bought, you just like it, you're allowed to use pretty much any graphing calculator that you want. Just let me know that you have a different one, and we can just have a chat about it, but you're allowed to use it. Okay, so let's find where the cube roots are. So find the math button. We used the math button yesterday a little bit. So the math button is right here, and when you hit the math button, you get a whole bunch of menus. You see up the top, there's some different menu items. You can arrow, there's your arrows right here. Right here. So you can arrow across to see different choices, but we want to stay in the math menu. And if you look down, number 4 is your cube root. Okay, and again, different calculators might have this in a different place. That's why it can get kind of confusing if we're using different calculators. So I want to use the cube root, so I'm going to use number 4. You can either arrow to it or just use the quick button, which is number 4. So if I just hit the 4, it'll give me a cube root on my screen, and then I can type in, for example, 16.
Good afternoon, Countryside.
Special number, both a perfect square and a perfect cube.
Time and will please release your juniors only to report.
We'll miss you guys. Don't forget Canvas.
Once again, teachers, that our class of 25 juniors only.
Goodbye, guys. Take your phone. 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 Okay, so that's how you do it on the calculator. Now, Mrs. Shackton and me, Mrs. Morse, we teach the cubes with a little, what's the word? Starts with an A. Acronym. I always forget that word. Bye, guys. Take your phone. Take your phone if you didn't. It's called SOAP. That might ring a bell for you. Okay. What SOAP stands for is the signs that we have to put in these parentheses. So SOAP stands for same, opposite, always, plus. And we're going to do 2 of them, a sum and a difference, which is the same process pretty much. So we'll do it twice. So if you look, whenever we have a sum or difference of 2 cubes, we're going to make a small parentheses. There's going to be a binomial in that, so 2 terms, and a trinomial in the second one. So I say like small parentheses, big parentheses. And again, SOAP is same, opposite, always, plus, or always positive. So what that means is same. So whatever the original problem is that they gave us, that's what goes in the first one. So that's our same. Then we do opposite over here, and then always plus or always positive. So that matches up with what they wrote there. So that's a way to just get the signs done, and then we can just fill in those 5 blanks with what we need. And so here we go. Just like we started with the square root of 9 and the square root of x squared, we're going to do the cube root of 27 and the cube root of x to the third. So the cube root of 27, if you need the calculator or whatever, it would be 3. And the cube root of x to the third is just x. And it just goes in the first spot. The cube root of 1 is just 1. 1 times 1 times 1. Okay? So there's our first set of parentheses done. Now, we don't even use the original problem. We're just going to use these 2 terms to fill in the blanks. So watch. What I'm going to do is square the 3x, and that's going to go right here. So when I square a 3, I get 9, and when I square x, I get x squared. Now pause. If you multiply these 2 together, you should get that term. So it's a really good place to kind of do a check, real quick mental check. 3 times 9, 27, x. Okay, yep, I look good. All right. We're going to do the same thing. We're going to square the last term, and it's going to match up in the last place over here. When I square a 1, I get 1. And pause again. If I multiply 1 times 1, I should get whatever is right there, and I did. Okay, so that's just a good way to know that you're on the right track. And that just leaves 1 spot, and that's right here. And all we do is multiply these 2 together. 3x times 1, don't worry about signs. Those are done for us with SOAP, and that's our final answer. Not difficult, just you have to remember the steps, okay? Let me do another one, but let's do a difference of 2 cubes. Same idea. Let me write it down first. Let's go 64x to the third minus 125. So again, it's got 2 terms. I see an x to the third stands out really easily to me. I go, oh, this is a SOAP problem. SOAP problems mean I'm going to do a small parentheses and then a bigger parentheses. Okay? And do my same, opposite, always, plus. So same, whatever this is, is my first sign. Opposite of minus is plus, and then always plus. Fill in the blanks. Remember, I just showed you 64. 64 is a special number. It's a perfect square and a perfect cube, so don't get them confused. We're doing cube roots, so make sure you put a 4. So the cube root of 64 is 4. Cube root of x to the third is just x. Cube root of 125 is 5. Now remember, we square these. Ignore the original problem. If I square a 4 and an x, I get 16x squared. Pause. If I multiply those two together, do I get 64x to the third? The answer is yes. Good news. I'm going to square the 5. Don't worry about the sign. Just square the 5. 5 squared is 25. Pause. Ask yourself, is negative 5 times 25 negative 125? Yeah. So just a good way of knowing you're doing it right. And then lastly, you multiply the 4x and the 5 together. Sorry, I'm squeezing it in here. And I get 20x. Okay? Now, sum and difference of two cubes, not difficult, but they're not as common. We don't see them a whole lot, so we kind of have to review them every once in a while. But that's that, okay? So those are our two terms. This next section is the most common ones we see, okay, is when you have three terms. They're called quadratic trinomials, okay? So there's three terms, and the biggest exponent, known as the degree, is a 2, right? Now, let me give you the first problem, and then I'll give you my little factoring speech. I'm going to go over this way. Okay, so our first one looks like this. X squared plus 15x plus 56. Okay, three terms, 1, 2, 3. And it tells us what it's going to look like and how to get it. Use two numbers that multiply to get together to get C and add together to get B. Okay, so where's A, B, where's this B and C business? So you can see it's in here. Okay, now I call these the chart problems. Just my shortcut to remind people. But the truth is, some of you learned these using like an X. Some of you just do it in your head. Some of you do something called guessing and checking. If you lined up 15 algebra teachers and asked them to teach that problem, you'd probably hear like 8 different methods. There's lots of methods to factoring, and none of them are necessarily wrong unless you get the wrong answer. So as I show you this example, if you're like, oh yeah, I remember my favorite Algebra 1 teacher in 8th grade or whatever taught me this method and that works for me, you keep using it. Okay, so if you have a method that works for you, you do not have to make a chart like what I'm going to do. But if you don't remember these or you ever struggled, I recommend you use the chart. But I'm not looking to see if there's a chart on your paper. Okay, we're past that. A lot of showing work. We're past a lot of that in this class. Okay, so what this chart is that I'm talking about is, it's a real simple like T-chart. I'm looking for two numbers that multiply to get something and add something. Okay, so I would just put a times and a plus. So back to this, it says we want the two numbers that multiply to get C. So C is the 56. It's a constant, so number at the end. And add to get B. B is 15. So I define the same two numbers for both columns, same sign, same everything, that make both columns happy. What numbers? You can just yell it out if you know. What numbers multiply to get 56, add to get 15? Somebody. 7 and 8. Thank you. 7 and 8. 8 and 7. Doesn't matter what order you write it in. 7 times 8 is 56. 7 plus 8 is 15. Okay? There's only one set of numbers that will work. It's not like Olivia has one set, Kayla has another. Everybody has to have the same numbers. It won't work. That's usually the hardest part for people. Okay? Sometimes the number is not as simple as 56, like a number you had to memorize in 4th grade, 7 times 8. Sometimes the numbers are in the hundreds, and you have to pick up your calculator and try different things. Okay? So don't get frustrated. This takes some practice. Okay, once we have those numbers, we're ready to write our answer. Two sets of parentheses. We're going to split the x squared in the front of both of the sets of parentheses. And the numbers that are in your chart, just come on down. We're going to put plus 7 and plus 8. Why plus? Because they're positive. If they were negative, we'd put a minus. Any order. You put the 8 first or the 7 first. It does not matter. And that is your final answer. Okay? So those are the easier of the two types of three terms. And I'm going to show you what the difference is between them right here. You doing okay so far? Is it coming back to you a little bit? Say yes. Lie to me. Yeah. You're not lying. Okay. We're almost done. So let's do one more of these. Again, 3 terms, it's again called a quadratic trinomial. What's different is we now have an a value. I don't really love that they left off the a value here. It's just that a was 1, okay, in that first example, right? If you don't see a number in front of the x squared, we know it's a 1. But once they throw a number in front, there's some extra steps. So be aware of that, all right? But we still start using the chart or doing it in your head. Again, I don't need to see the chart. So I'm looking for 2 numbers that multiply to get something and add to get something. Same 2 numbers, make both columns happy. The difference is we include the a. So to get this number, we do a times c. So it's 3 times 10 is 30, whereas in the one we just did, we just cared about c. But technically, it was 1 times what was in front, which was just the c value. And the b value still goes here. Be careful, guys. If there's a negative in front of a number, it is part of that number. It travels with it. Okay, that's really, really important. So that's why that's a negative 31. So here's that hardest part. Not hard, but the hardest, if you want to say something's hard, is finding those 2 numbers that make both columns happy, signs and everything. Okay, 30 has lots and lots of factors. 2 and 15, 3 and 10, 5 and 6. But none of those will add or subtract even to get 31. Anybody know what the numbers would be? 30 and 1. Good, Olivia. So before I worry about signs, I'm just going to get those numbers written down. 30 and 1, or 1 and 30. It doesn't matter, okay? So 1 times 30, ooh, that works. 1 times 30 is 30. 1 plus 30 is not negative 31. That's okay. We're going to play with the signs to make it work, okay? And in this situation, to make a negative 31, both of these would be negative, okay? So that makes that guy happy, but make sure it works over here. Negative 30 times negative 1 is positive 30, so we're good, okay? So this is kind of like, I call it like your workspace where you could make mistakes. Oh, that didn't work. Let me try something else. Oh, I messed up my signs. That's just, you can do it in your head. You can do it on paper. A lot of you have learned with an X method. I tried to switch over to that method because I think they teach that in 8th grade, but I just couldn't, okay? Now, because of the 3, remember I told you this makes it a little bit harder. There's more steps. I can't just write my answer. In the last example, when I had these 2 numbers, I could go right to my parentheses, done. But because of that, there's extra steps. So here they are. I'm going to bring down the outside 2 terms. Do I need to see arrows? 100% no. Okay, I'm just showing you. So I'm going to bring down the 3x squared and the positive 10. Remember, the sign in front of a number goes with a number. So I start out, just bring those straight down, and then I split the middle. I'm going to split that middle term into these 2 numbers, just putting a variable on them. The order doesn't matter. I can put 1 first or 30 first. Negative 1. Just know that you have to put an X on them both. Those 2 numbers in the middle should equal the one above it. We're not breaking any rules. Those 2 equal that. Okay? I swear we're almost done. Now that there's 4 terms, we do the grouping method, which, by the way, our very last example starts at this step. So we're going to practice this step again in a moment. So what we do is we do grouping of the first 2 together, grouping of the second 2 together. Grouping. And we treat these like 2 separate little baby problems. What you're looking for is the GCF of the first 2 terms. What do they have in common? The greatest thing they have in common. Sometimes it's a number, sometimes it's a letter, sometimes it's a number and a letter. There's no rule about it. There's got to be something, even if it's just 1. Like your very first example in your homework, all they have in common is a 1, so you have to put a 1. But these 2 actually have more than just a 1. They have an X, 1 and an X. So we'll just put X. And I've seen where some people like to show it here. What we're basically doing is dividing both of those by X. Whatever's left goes in the parentheses. Okay? So when I divide 3x squared by x, I'm left with 3x. And when I divide that by x, I'm just left with negative 1. Again, there's a very easy way to check this by doing the distributive property. X times 3x, 3x squared. X times negative 1, negative 1x. Looks good. You do the same exact thing to the second set of parentheses. Anytime the third term is negative, whatever you factor out has to be negative, okay? You'll see it again and again. Anytime this guy is negative, whatever you're going to take out, whatever it is negative. Those two have what in common? What number? 10, okay? So we're dividing both of these by negative 10, and whatever we have left goes in the parentheses. And if we're doing it right, which we are, whatever we get in this set of parentheses should match identically to this set of parentheses. So negative 30 divided by negative 10 is just 3, and that x is there. Yay. And positive 10 divided by negative 10 is negative 1. If you forget to make that GCF negative there, the signs will be wrong. You'll be like, oh, I forgot to make it negative. So as long as you have identical twins in the parentheses, you're ready to write your answer. Here we go. Final answer is going to be 2 sets of parentheses. Now the order you put these in doesn't matter. Notice what's in the parentheses here, the twins, 3x minus 1, put it in one of them. It doesn't matter which one, the first set or the second set. And then the x minus 10 that's left over, x minus 10 is the other set of parentheses. Okay, this is probably the most common type of factoring we have to do, and it's probably the one that people make the most mistakes on. So tomorrow when it's review time, make sure you do some extras of these and that you're getting them right and letting me help you if not, okay? Because these are really, really common. You've got to be good at those. Let's kind of practice that type with our final example because they're almost the same, just these are easier. Last one. When there's 4 terms, we factor by grouping. So let me give you guys an example. That's an arrow. Four terms, easy to tell. It's very recognizable. 4 of them. You go, oh, this is a grouping problem. 2 and 2, exactly like we did in the middle of that last problem. These two, and GCF it up. So in the first set of parentheses, I'm seeing a mistake a lot where people just put x. Remember, G stands for greatest common factor. They have an x squared in common. They have 2 x's. Okay, so that's my GCF. And if I want to divide each of these, whatever's left goes in the parentheses. So I would have 8x plus 1. You have to have a binomial in there. Here's why. Remember, if you were going to check this, if I distribute this x squared to these two, I should get this. Okay? If I leave that 1 off, I won't get that. Right? Don't forget, if this guy is negative, your GCF is going to be negative. Sometimes it isn't. A lot of times it is, for whatever reason. And then these two have a 4 in common. So I'm just dividing these both by negative 4. And I have 8x, yay, negative divided by negative, positive. You check it by distributing. Things are looking really happy for us here because of the parentheses being the same. Ready to go to that step of putting it all together. So remember, these should be the same. They are. Pick a set of parentheses you want to put it in. And then what's left over. So the order doesn't matter. But does anybody notice one last special thing here? Come on, come on. Yes. Thank you. Casey? Make sure my pen's on the right way. Yep. So guys, our final step 3, ensure no factors can factor any further. Just like yesterday, how did you know when you were done? That was half the battle, right? Can I simplify my radical anymore? Can I simplify a fraction anymore? Can I factor anymore? See, these pop up a lot in the middle of a problem. That's the difference of 2 squares. We just did it a second ago. This one I'm just going to bring on down. I can't simplify that one anymore. But this is x plus 2, x minus 2. So they sneak up on you. Always, before you walk away from a problem, make sure there's nothing else you can do to it. Okay? So I basically just taught you a whole chapter in Algebra 1, a whole chapter in one class period. Hopefully it was a review for most of you or all of you, but now you know how much work you need to put into this if you're not feeling confident, okay? So I'm going to tell you what 4 problems to do for the assignment, and I'll come around and help you. So if there's something you need clarification on, it's fine. Remember, you're allowed to work together. I'm happy to hear you guys working together. Okay. So all you are required to do is these 3, 1, 5, 11, 13. I have uploaded, or I'm going to upload the entire key, and we'll work on some more of these tomorrow as part of our review. But if I check A3, these are the only 4 I'm requiring you to do. I really took it easy on you. I'm really taking it easy on you right now. And it's really because we have another day tomorrow to kind of practice. So I'll put the key up for you, and I will come check on you momentarily. And then tomorrow be ready to have any questions on anything, and I will help you. Be ready for the quiz on Thursday. Okay. Here is... So remember, 1, I circled them, the 4 that you need to do.